Hi everyone, this is Arya and this is my very first video. In this video, I have made an attempt to walk you through this project of mine based on exploratory data analysis. This has been done as a task functioning as an intern for the Sparks Foundation, and I'm very glad to have got this opportunity to explore data analytics and business analytics as a whole through this. Now, to begin with, exploratory data analysis, or EDA as it is commonly abbreviated as, is a storytelling tool which is loved by data and business analysts. Since I've always loved storytelling in every form, this endeavor helped me dive into the data part of it. EDA helps you to explore and understand the data, analyze it, and finally draw inferences from the same. Now, how and why does this matter to you? It does matter since everything you do as a business involves data. Everything is revolving around data. It helps you take decisions, more informed decisions particularly, and those oriented to the growth of your firm as a whole. Talking about the steps involved in exploratory data analysis, there are essentially three steps which are involved. The first one would be to understand the data. Initially, you try to load the data and you try to figure out what the data is trying to convey to you. What are the different columns in the data, how many rows are there in the data, and the different aspects of the data set. The second step involves cleaning the data. Since you cannot possibly deal with this super large data set, and hence you try to clean the data. You try to avoid the redundant data, you try to remove the null values and everything. So this essentially is called cleaning the data. The third and the final step is known as relationship analysis between the variables. In this relationship analysis, you try to use visualization tools available to you and create an understanding of how the different variables depend upon each other. Now, moving to my project now, here the data set has been extracted from a retail store which is functioning across the United States, and the various statistics involved, the sales, the profit, the discount, and whatever you name. I have used Python, but to do the same you can use different tools like R, SAS, or anything which you lay your hands on. Moving on. So the first step, I have imported the libraries which I'll be using in Python. I've imported pandas, numpy, seaborn, and matplotlib in that order. Next, I've tried to load the data set. And again, I have tried to display I have used the head function and the tail function in order to display the first 5 entries and the last 5 entries, which gives me an idea of the columns involved in my data set and the number of entries. The last entry says 9,993, which says that there are 9,994 entries in my data, which is quite a large data set to deal with. Next step, as we said already in the introduction, is cleaning the data. Now, cleaning the data here, I have tried to remove the null values, although there were no null values since I checked it out in my data set, so I could skip that step. But if you get a data set in which there are null values involved, what you can do, two stuffs over here. Either you can remove all the null values or you can average out the other values and insert that value in place of the null value. That would essentially give the same result and would not distort your data set or your inferences. I have removed the duplicate values. I've tried to use the nUnique function to calculate how many unique values are there in each column, which gives me an idea that there are 4 shipping modes, there are 3 segments, 1 country because our store performs in the US only. Next, since I was cleaning the data and I kind of realized that I do not need the postal code to draw any inferences from that. I do not need it, and hence I dropped the data. I dropped the postal code. I dropped the duplicates in this step. I moved forward to visualize the data. Now this visualization has taken place using several tools, several different types of plots and charts. The first one is a correlation matrix, which has been implemented using a heat map, which you can find in the Seaborn library. In this correlation matrix, what I've tried to depict is the relationship between different variables. That is, I've tried to represent how much is the dependency of sales on quantity, how much is the dependency of quantity on discount, and several other parameters. This here I've dropped the postal code which I mentioned in a step earlier. Next, here I've used a pair plot. Now, why do you use a pair plot? As you can see, there are a lot of graphs. There's 16 graphs over here. So why is a pair plot used? A pair plot is a tool which helps you to visualize multiple pairwise bivariate distributions. Now, here I'm using bivariate distribution, implying the relationship between two variables, the profit and the sales variable, or the profit and the quantity variable, or the discount and the discount variable, which gives you this graph for different hues. Again, here I have used the function called value counts to count the number of entries for each class. And again, I try to depict it using a bar graph or a count plot. In order to make it more interactive, you can use different colors. I have done the same thing for segment and other parameters, the count plot and the pair plot. For category, as you can see, we have three categories of items which the store delivers. And the category includes furniture, office supplies, technologies, etc. Here, I have used a pie chart to depict how much supplies are there in each category. Pie chart works quite fine to give you that idea. Next, I try to represent the number of sales in different states of the United States, which gives us an idea of the very uneven distribution between the states like California and New York, where the sales are comparatively high, and the states like West Virginia and North Dakota, where the sales are negligible. This gives you an idea about how your store is performing in the different states, performing across different segments. Again, a pie chart to show the distribution of performance in the different regions, which is fairly even. Here, this is a different kind of plot which is known as a scatter plot, and it is known to give us a very good idea about the dependency of two variables, which in our case is the profit and the sales variable. We can see that the dependency here is quite large since the plots or the dots are concentrated in a certain region, whereas they start getting distant as they move towards higher values. Another different kind of a graph is the line plot. I have used the line plot to depict the relationship between profit and discount offered by the store, which is linearly increasing and then steeply decreasing and then again increasing over time, which can actually give the owner or the business owner and the analyst an idea about how the store is performing, what is the inclination of your customer base and which products can you focus on. Again, the profit versus quantity graph over here. In this one graph, I've tried to depict what is the distribution across profit and sales for different segments. You can see that across the segments of consumer, corporate, and home office, although the sales varies by quite a large extent, but the difference in profit is minimal. What does that show? Is our store actually performing well? This another kind of graph shows us the segment-wise sales in each region. The regions include East, West, Central, and South. Again, this graph tries to show the region-wise profit loss and sales. Again, the difference in profit loss versus sales is quite large in all the regions. Across states, we can see in this graph quite clearly that the profit in California is quite much compared to the profit in Texas, which is in the negative, or Pennsylvania, which is also in the negative. So these graphs give you an idea of how the store is performing and what measures should you take to proliferate your business towards growth. And this again shows us the 10 largest values of the 10 cities or the 10 states actually in which your business is performing quite good, it is flourishing. So this can actually help us to, help the store owner to decide that they can implement the California model in Texas as well, or in North Carolina as well. And this final graph gives us the relationship between profit loss and subcategory. This graph shows us that the performance in phones and performance in copiers is decent, but the performance in machines, tables, and bookcases, yes, bookcases is not up to the point, and probably we could stop operating in those, or we could try to improve the quality of our product. So all these graphs help us present a pictorial representation of all the inferences we can derive from the data available to us. And that is why this method is very widely used in order to get idea about whatever how your business is performing, what measures you need to take, in which direction is the business inclined to, and several others. Thank you.